Okay, good morning. This morning in my area. I don't know. You'll be watching this during nighttime. But anyway, I'll be solving as many problems as I can so that at least you can say that I've done my best. Okay, so I'll be solving that problem which is on the screen. Then I will tell you what are the things that is really happening in my mind if I'm really trying to solve a particular problem. For example, like this one, I'll be writing, of course, the whereabouts. The whereabouts. Basically, contains the given and the given, what is asked, or probably simple description of what the problem really is. And then also, it might contain also the analysis because someone says, there you go, that a problem that is half analyzed, a problem that's already analyzed is already half solved. And by doing that, you will really improve. Okay? So based on that problem, as you can see on that screen, basically I'll try to write the um, this one is more important, the numbers, those numbers that are seen, because we're dealing with numbers, of course. This is Analytical Chemistry 101. Okay. Primary grade standard of mercurous. It's GO, mercurous acid. You don't have to pronounce that correctly. So it is a solution of another hypochloric, just like the other day. We have a solution of hypochloric acid, and then the reaction is given. You have your mercurous oxide, and then your ion, bromide, and then you have your water. So these are, I think, the most important thing that I have to ponder on ever I'll be solving problems for titration. So as that you can see how I manage to analyze. Liberated OH consumed, so there is a liberation of OH, so meaning this is the product OH, that's why it says the liberated OH consumed. So meaning this one, as the reaction happened, since it consumed the acid, calculate the molar concentration, the molar concentration of the HClO4, so this is the acid. So you want to calculate how many, what's the concentration, the molar. Calculate the molar concentration of your perchloric acid. Maybe I have to make it less like this. HClO4 and then question mark. Okay, you have, and then probably I'll try to draw. You have a solution of HClO4 was standardized. So this is HClO4 which was standardized by a primary standard HCO. So basically your HClO4 will be a secondary standard. The volume is already given, that is the volume. So if we try to plug it from the equation for the 3.75 ml of the acid. So if you try to find, I'll start probably my solution because that's how I do it. Probably I'll start the solution, probably analyze it again. Anyway, so solution, I'll start from the definition of your molarity, the concentration of your HClO4, which is I'll be doing most, not the plug and check type, because as I was referring to the LPI, I always do this. That would be the number of moles of your HClO4. Actually, the volume is already given. That would be the 43.75. And then change the milli into 10 to the negative 3 liters. Okay? So basically, that number of moles of HClO4 perchloric acid would come from your 0.4 OH and of course with your stoichiometric ratio. So that should be it, because you are asked to calculate the molarity of your perchloric acid, wherein this amount of acid consumed the OH. So, and basically the OH will again come from your primary standard mercurous acid. So basically, it must come from this one. And anyway, there will be no doubt because there's no other numbers that we're giving there. So they should be related. Of course. Diba? So you have to replace this with, of course, the number of your OH. So you have to replace this in terms of stoichiometry. So you have to replace this in terms of your OH and then relate it once again to your 0.4008. Okay? I think plug and chug is the best way for this one. But I'll try to find another route. Anyway. Okay. So plug and chug. Diretso na ladayon. Okay, plug and chug na. So it must come from the 0.4008 grams of your HGO. And then you will use the stoichiometry and you will use probably formula weights if ever you'll be converting them from one unit to another. Okay, the first problem here because is converting your mercurous acid to somewhat mole, in terms of mole, because your stoichiometry is talking about moles. May check the video ba? Parang I could just edit and just edit. Edit. So we go to your periodic table. Your periodic table gives you mercurous acid to be HGO that is 216.59. So the formula weight for this one is 216.59 59 grams per mole. So by that, you'll be needing the grams at the bottom, and then of course your mole would be at the top. Mole of this is 216.59 grams of your mercurous acid over 1 mole of mercurous acid. So after that, you will be now using the stoichiometry. The stoichiometry says that for every 1 mole of your mercurous acid, it would liberate or it would make a product of 2 moles of hydroxide. 2 moles of hydroxide, 2 moles of OH per 1 mole of your mercurous acid. So after that, you change your mercurous acid to your reaction with respect to your perchloric acid. As you can see, your OH would give us an acid-base reaction. So you can write it or you may not, but you know that for every 1 OH, there should be 1 H for it to make, of course, your water, HClO4. So the reaction of that, it would give you an H2O, and of course your ion, which is the perchlorate, I think. So I might be saying the wrong words for that, but anyway, that's understandable if you just say ClO4 negative. Okay, so meaning you would be needing 1:1. So for every 1 mole of your OH, that is equivalent to 1 mole of your HClO4 for every 1 mole of your OH. By that, you already have a unit of mole of HClO4 per liter of that HClO4 that was used to, of course, have that acid-base reaction for your HClO4. I mean, for your OH that was liberated from the stoichiometry. Okay, so you already have the right unit. Basically, you arrive at the right answer. Simple as that for a plug and chug. I think for this type of problem, formula-wise, there will be a lot of story because you'll be connecting. You better really improve the plug and chug method for this one. There are really type of problem that if ever you will not be using the plug and chug, it will be cumbersome in terms of so many attachments you have to incorporate with a particular compound. So that's what makes it complicated. Unlike for a plug and chug, as you go along with the plugging method, the problem becomes easier and easier. So that's my advice to you. Okay? I guess I cannot show you another solution for this one. Can I? I think I cannot. Oh, I might be thinking a lot of things before I can. Anyway, I provided you already a simple solution for this one. Cancel, this will be cancel, this will be cancel. As you can see, you have the unit of your HClO4 times 2, and then all the numbers at top, all times 10 to the negative 3, and then you have times 216.59 unit now would be mole of HClO4 per liter of solution. So by that, that is already the molarity. Get our calculator. You have 0.4008 times 2 all over 43.75 exponent negative 3 multiplied by 216.59. By that you have 0.0846. 0.0846 mole per liter. That's the number, the molarity of the HClO4 that was used to titrate. Of course, this is titration. So basically, if that OH was liberated in the solution, you just drag it with HClO4 as your titrant, add it within HClO4. Because as you can see, for a titrant, that's what we're trying to measure, how many volume of that is really reacting in the vessel. So here is your reaction between yields and OH. So anyway, and then you don't have to mind the other thing as long as you know what's happening. And then you drop the HClO4, which is the final part of what we're doing. Okay? Thank you guys for listening.